We understood that the Internet is vast, and we understood it is divided into autonomous sections. And we also understood we have a routing protocol inside the autonomous section and also between the autonomous section. Let's begin inside the autonomous section. We can also call it IGP, Interior Gateway Protocols. Usually, the known protocols within Intra-AS are Routing Information Protocol, or RIP, or Open Shortest Path First, or OSPF, and ISIS. There is also something less familiar, IGRP, but we will focus on OSPF and RIP. Let's start. Open Shortest Path First, or OSPF, is open based on link state. As we recall, link state is like Dijkstra's algorithm. Link state has the complete picture of the topology. It's global. And to create this picture, each router must distribute its situation to publish it to all routers in the same AS. It means that I need to send OSPF messages on top of the IP protocol and distribute it to every router in the network via flooding. Once they receive it, each one from everyone, each can construct the complete picture and run Dijkstra to understand what are the lowest cost paths. OSPF's interesting features are security, the ability to receive only authenticated messages, meaning I don't want anyone who is not authenticated to send me information or confuse me with the wrong topology. I can have several paths from A to B that have the same cost, and I save them, they are different paths. Per link, I can also save several metrics so I'd have several costs. Say, to decide that a certain link's cost is 3 in one case and 4 in another case. And the differences are in the type of service, for example. I can also do a unicast, one-to-one, as well as multicast, one-to-many. And as we recall, OSPF needs a global picture. What happens if my AS is very big? What does very big mean? Many routers. To run such an algorithm, to distribute these many messages to many and run it, it's a lot of messages and a lot of calculations. Therefore, a hierarchical element was created. What does the element look like? It's simply a division into areas plus another area, the backbone, which is usually called area 0 that connects between them. It creates a situation where we have routers within the area, routers that are both in the area and in the border, and routers only in the border. And of course, one router or more that transfers us to other ASs. What does this create? It creates a situation where, as though we have taken an AS and transformed it into small ASs, and in each small AS, we run OSPF, and then the backbone, where we also run OSPF. Knows to convert from Area 1 to Area 2. Therefore, we have a two-level hierarchy. We have the area border routers, we have the backbone routers, and there are the routers that connect us to other ASs, which are the boundary. In summary, OSPF has a global picture. It's very widespread, works with Dijkstra for paths, the entire link state should be distributed, and it has interesting features. And it's one of the most common protocols for intra-AS routing.